This is C channel, and we will solve it in the Matlab. So they give the question that this is C channel and determine maximum shear stress and applied shear stress 20 kilonewton. That means this B is 20 kilonewton, and shear stress at point A and point B are same there. Why this is same? Share stress at A and B same. So let's go main MATLAB scripts. So I save this image as C here. So let's run it, and okay, this come in here. So I undock it. Okay. So you see here there is neutral axis distance, moment of inertia. This is this term is called shear maximum shear stress occur on the neutral axis, and tau max, qb, and other parameter. So let's talk about the code. So I input here the maximum shear according to the question. You see the question give the shear b, and I define this thing w, and w is 5, 1 plus 3 plus 1, 5, and h here, h is total 5 minus 1, that will give you 4, and t1, this is t1, this is 1 inch, and this is t2, this is also 1 inch. So this is the formulation section for A. So first we have to determine the neutral axis distance. So we take this is our reference line, and from this we will determine the neutral axis distance. We call this yz. So for this w multiply t2 and divided by t2 divided by 2 plus this thing t1 into h, and multiply h by 2 plus this distance, that means t2, and there is a one flange, there is another flange, so multiply here 2 divided by their area, that means w multiply t2, and this h multiply t1, there is two flanges, so multiply 2, and then moment of inertia comes in here again. In this way you can find the yz, I mean neutral axis distance. So you see in here how much it is, 2.0.03. So that means it comes nearly here, 1 is nearly here. So then moment of inertia, so it is again bh cube, 1 by 12 bh cube, bh cube, that means for this plane this is 1 cube plus, and again w into t2, its distance, I mean its neutral axis center of gravity distance is half, right? 1 divided by 2, that means it will give you half. So we have to make with reference to neutral axis. So neutral axis is here 2.03 from here to here. So if I deduct minus half, then it will give center, this center to this center, when this neutral axis to this neutral axis distance, that means a d square. We know this formula, 1 by bh cube plus a d square, and plus this thing again, this is bh cube, b is t1, h cube is, and this thing plus a d cube. So a means area, t1h, into d means this neutral axis to this neutral axis distance, again h by 2 plus t1 gives this height, and deduct hg yz, it will give you center, neutral axis to neutral axis distance. And there is again maximum shear stress occur at QA. So we take here uh, T1 multiply T2 plus H, that means this whole distance, minus YZ. This YZ will gives like this distance, and multiply their distance. So T2 plus H minus YZ divided by 2. So there is two flanges there and there. We take these, I mean neutral axis in here. Suppose that neutral axis in here. So we have to take this thing and this thing area, multiply their neutral axis to this neutral axis distance, and then TA is 2 into T1. That means this width plus this width, we call this TA. That means section width at neutral axis. We need this thing for tau max, maximum shear stress in Q. That means BQ divided by ITA. TM is this thing again. And for question part B here, explain if shear stress at question A and B are the same. So here they want shear stress at A and B. You see here A and B. So mainly shear stress uh, depend on QA, IA, TA. That means this again related with the area, right? So you see here the thickness and their area same. A and B and area same. So the shear stress at A and B should be same, since the section width, shear and area shear and moment of inertia are the same. So let's talk about QB. We multiply here WT2, this Y area, multiply YZ minus T by 2, then it will give us this Y flange QB, and TB is the effective width, W, and tau B again this B into QB divided by I. So again here we define in here 0.03 maximum tau. This will maximum shear stress tau max and maximum shear stress at B here. So let's run it, unlock it. Sorry. So here the maximum shear stress and minimum shear stress. So in this way, if you want to solve another problem, just change the parameter in here. Just change the input, and you can change the thing. So if you need the code, please give a comment on my video. Thank you. If you like my video, subscribe my channel.